In this illustration, we'll analyze a case where a bar with a load supported by two rods. We are given that two rods A and B of equal free lengths hang vertically from ceiling 60 cm apart and at bottom attached to a light horizontal bar. Bar remain in horizontal position when carry a load of 5000 kg at a distance 20 cm from rod A. And it is saying if the stress on rod B is 15 Newton per mm square, we are required to find the stress in A and cross-sectional areas of A and B. Young moduli are also given for both of these rods. Here, first to understand the situation, we can draw the figure. If this is the ceiling from where two rods are vertically suspended in the manner I am drawing here, and at the bottom they are supporting a light horizontal bar. Say if this is rod A and this is rod B at a distance 20 cm from A, we have attached a load of weight 5000 kg on it. So due to this, say tensions developed in the rods are T1 and T2, due to which a stress will be developed over here. And as the separation between the two rods is 60 cm, this length would be 40 cm. Now in this situation we can write for equilibrium of system we use, here we can use one thing is T1 plus T2 should be equals to the weight of this block, which is 5000 G, that can be written as 50,000 of 5 into 10 to power 4 Newton. And we can also use, if this point is O, with respect to point O, the torque of the two tensions in the rods must be same. So here we can consider T1 multiplied by 20 should be equals to T2 multiplied by 40, which results T1 is equals to 2T2. And if this equation 1 and this equation 2, then we can use from 1 and 2, the value of T1 we can calculate. If we solve these two equations and if substitute T1 as 2T2 over here, we are getting T2 is equals to 5 into 10 to power 4 divided by 3. And the value of T1 is twice of this, which is 10 to power 5 divided by 3 Newton. So these are the values of T1 and T2 we obtain. And as we are given that the bar remains horizontal, we are already given. So we can write as bar remain horizontal. This implies both the bars are elongated by equal lengths. So we can write here the strain in rod A must be equal to strain in rod B. So strain we can write as a stress by Young modulus. So this gives stress in rod A divided by Young modulus of A should be equal to stress in rod B divided by Young modulus of B. And we are already provided with the stress in rod B, so this will give us the stress in rod A. So here we can write the stress in rod A is equal to, here we can write YA upon YB multiplied by stress in rod B, and numerically we can calculate as all values are given to us. YA is here YA and YB we can substitute. The value of YA is given to us as 2 into 10 to power 11 divided by 9 into 10 to power 10 multiplied by 15 Newton per mm square. So this will give us the result as 1000 by 9 Newton per mm square, which is one result of the problem for the stress in rod A. And we are also required to find the cross-sectional area of A and B. So here we can continue from this point, as stress in A is given as 1000 by 9. This we can write for A. 1000 by 9 will be equals to T1 by A1, which will give us the value of cross-sectional area of rod A, and we can substitute this value as A1 is equals to this 1000 by 9 multiplied by A1 is equals to T1. So the value of A1 is T1 divided by 1000 by 9. So here we can write it as 9 by 1000 multiplied by 10 to power 5 divided by 3 multiplied by 10 to power minus 6, because we are given the stress in Newton per mm square. So this is giving us the value of area of cross section for the first rod, which is 3 into 10 to power minus 4 meters square. And similarly, if we calculate for B, then for B we can write the stress is given to us as 50. So 50 will be taken as T2 by A2, which gives us the value of A2. That is equals to 5 into 10 to power 4 by 3 divided by 50 into 10 to power minus 6. And numerically solving, this will give us a value 10 to power minus 3 by 3, or it is 1 by 3 into 10 to power minus 3 meters squared. These are the another results of this problem.